Okay. Hello, everyone. Thank you for coming to today's meetup. My name is Arne. I'm engineer here at Driving Ways Labs. Little bit the host today. And talk today is Apache Pulsar and the convergence of messaging and streaming on the cloud. Our speaker for that is Penghui Li. He's from StreamNative. He's an Apache Pulsar committer and PMC member, very passionate about helping organizations with their architecture and implementation of messaging services. Before StreamNative, he was software engineer at Zhaopin, where he was leading Pulsar advocate and helped companies to adopt and implement the technology. So yeah, I hope I didn't forget anything important. And the stage is yours. Do you hear us? Can you?
Yeah, I can hear you.
Okay, please feel free to start your presentation.
Okay, thanks for the introduction, and yeah, let me share my screen.
Please do so.
Yeah. Yeah. Can you see my screen?
Yes, we can see.
Oh, yes, thanks. And yeah, you can call me Penghui. Yeah, it's I'm from StreamNative and working on Pulsar for 4 years, I think. Yeah, and yeah, before start the talk, and if you have any point you want to discuss, and yeah, you can interrupt me, and feel free to interrupt me. And let's start. And yeah, I will if we have one sentence to describe what is Pulsar, yeah, I think it's 3 keywords. It's Apache Pulsar. It's a cloud native and a distributed messaging and streaming platform. Yeah, and my talk also it's have 3 parts. It's for the first part, I will introduce the architecture of Pulsar and some key features of Pulsar, and the second part is about the resiliency. Is about how Pulsar handling the failures, and the last part is about the operability. It's about how do you operate Pulsar every day, and how to do the scaling, yeah, something. Yeah, so yeah, let's say it's the Pulsar architecture. When we talking about the Pulsar architecture, yeah, I think it's the first one is the multi-layer architecture. It's the big difference with other. It's Pulsar. It's have a very different architecture with other message queue architecture. It's for example Kafka or Runtime queue. Yeah, because it's Pulsar has two layers. It's the first layer is the broker, and the second layer is the Apache bookkeeper. It's looks like 2 open source project. Yeah, and also it's the difference for the 2 layer is the for the first layer it's a stateless. It will not persist any data to the local storage, and it's just the producers and the consumers can connect to the broker, and all the topics will distributed to all the brokers. And if a producer writes a message to a topic, and the broker will try to write the data to the storage layer. And if you have maybe three replay cards, and the broker side will try to write the 3 replay cards, and yeah, so the broker don't have any local storage, and so it's easy to scaling, and for the bookie side, it's just for the storage side, it's don't have the concept of topics or something. It's just it has a concept named ledger, or we can think it's looks like a data segment. Yeah, you can have many data segment, and the data segment can distribute it to many bookie nodes. Yeah, so it's and the next page will introduce more details about this part. So for this page, you can see it's for Booker side, it looks like it's maintain all the topics, and all the client side producers, consumers will create connections to the brokers. So it is the difference. It's why Pulsar is different with other messaging systems. And the second one is it's also a big difference with other message queue systems. It's about the segmented architecture. Yeah, because we can for the if we compare with the Apache Pulsar, you can see for one partition or one topic, it's the data is stored in one broker. If you have 3 copies, and the 3 copies also located to other 2 brokers, and for each partition, you will have a directory, and under the directory you have many files. Each file is a data segment, but Pulsar is different. It's because for Pulsar, it's the topic is in the broker level, and so it looks like a logical topic or a logical partition view. So you can see if a partition have multiple data segment, and all the data segment will distribute it to the bookies. For the bookie side, it's the different is one bookie can have multiple one bookie, the data in one bookie can have multiple topics, and the data for one partition also can use multiple bookies. It's just maybe here you can see only have 4 bookies. Yeah, maybe you have more. You have 10 bookies or 20 bookies. Yeah, but the data can distribute it to 20 bookies for one partition. Yeah, so this is the big difference for Pulsar. And the advantage for this one is because if you want to scale up the bookies, you can just end the node and the bookie node, and the data will new data will try to distribute it to the new bookies. So it's easy to operate. And I will introduce this part in details in the following pages. And I think another one key point of Pulsar is the subscription type is because it's you can say it's for other systems, maybe you can only have one subscription types, like in RabbitMQ, you can create the consumer to subscribe to one queue, and you can have many consumers to subscribe to one queue. But in Kafka, you can have multiple subscriptions, and for each subscription you can have one active consumer, and other consumers. If other consumers connected to the partition, it will looks like a standby state. Is if the active consumer crashed, and the other consumers will one of the other consumers will become to an active consumer. Yeah, but for Pulsar, the Pulsar have different subscription types, and for each subscription type, it will have different behavior. For example, it's for the exclusive and failover subscription type. It's similar with Kafka. It's you can only have one active consumer that can connect to the to one partition. And for the exclusive, the failover is similar to the Kafka model, and exclusive means that you can only have one consumer to connect to the partition. If you have the second consumer try to subscribe to the topic, yeah, you will get filed. And so yeah, this one is used widely in the streaming case for the integrate with Flink or the streaming processing. Yeah, because it's for one partition, it's the Pulsar has the guarantee, the message dispatch ordering guarantee, and yeah, so but for the second one, the shared subscription, which means it looks like the traditional messaging queue model. So you can have multiple consumers can connect to one partition, and so it's the messaging dispatch to the consumers is in the Robin fashion. It's without the ordering guarantee, but you can try to scale up your consumers and scale down your consumers. So it looks like it's more flexible for the consumer. And the last one is the key shared. It looks like it's the dispatch ordering is based on the message key. It looks like you have a system, and looks like you have a order system, and the order system is you update the order state. It's maybe yes, change the state to another state. Yeah, and for each order you can have an order ID. Yeah, so that you can use the key shared subscription type to make sure it's for all the changes of one order will dispatch to only one consumer. So you can guarantee the ordering for a given key. And so, and it's for the key shared subscription, it's not limited. One partition can only have one consumer. You can have multiple consumers subscribe to one partition. So it's yeah, it's a more great for the consumer scaling. Yeah, so this is the yeah, and the Pulsar also have many other key features. Multi-tenancy, you can have one Pulsar cluster, but you can have you can have tenant namespace, and for different teams or groups and a product. Yeah, maybe it's because Pulsar can support the resource isolation for tenant or namespace. Yeah, and so that it's the Pulsar can provide the ability that you can have one large cluster to support the business of the company. Yeah, and the delay messages, Pulsar also supports the delay messages, which is widely used in the traditional message queue scenarios. And it looks like you can send a message, and you can set it's try to deliver to the consumer. Yeah, maybe 30 minutes later or something. And the delay message is only for the shared subscription. And for the third one is the transactions. It's Pulsar also support the support to use the transaction API to achieve the exactly once message delivery semantic. And Pulsar also support the protocol handlers. It looks like a plugin which you can and a plugin to support other protocols. Looks like for example, for Kafka, RabbitMQ, or MQTT. Yeah, so that you can looks like you can have a Pulsar broker which can handle messaging protocols, so that you can migrate your application easily to Pulsar without changing your code. Yeah, it's will help in this case. And Pulsar also have the built-in schema registry, so that you don't need to deploy separated services for the schema. And the geo replication is you can deploy a Pulsar cluster. It's a multiple local clusters distributed to multiple regions, and if one region is stop the services, or some failures happen, or one region is a local cluster is not able to provide service, but the other regions also have the data, and so you can also start to produce or consume to point to the other local clusters. And Pulsar also supports the tiered storage. You can offload the old data or the cold data to the S3 or some more cost efficiency storage system. The first part is more about the Pulsar basic concept of the Pulsar architecture and features. And this part I will deep dive into the resiliency for Pulsar. It's how Pulsar handling the failures. It's for the first one, I will talking about the broker failure. It's like one partition. It's an example. It's if you have one partition and the one partition have multiple segments, and all the data is stored in the Bookies, and the last segment is the active segment in Pulsar. It's because only the last segment the producers can write the data to the last segment. All the old segments will be closed. It looks like it's only read only. It's not able to write data. And if the broker is crossed, or the network is not work, and for Pulsar it looks like you can say it's a partition one. It's a partition one in broker one, and if broker one is not able to provide the service, and the partition one will go to another broker, for example, the broker two, and in this case, it's the topic will also try to roll over to a new segment. It's the segment X plus one, and the new segment will also distributed to multiple Bookies. So you can say it looks like the partition ownership change is very efficient. It looks like maybe only under several milliseconds. So it's because you don't need to copy data or something like Kafka, and so if for the Bookie failure, it's a little different with the broker side. It's if you have also the same example, if you have one partition and all the broker Bookie 1, 2, 3 is have the last have the data of the last segment, and if the Bookie 2 is crashed, or it's not able to recover the service, and so what will happen in this case? It's for the Bookie side. First it will try to replicate the segment to other Bookies, but here will not introduce any impact to the topic services. It looks like the topics will still work, and all the producers and the consumers can continues to publish messages and consume messages, and all the data replication is happening in the background. And so it's for the user side, for all the application side, it will not mention this failure, and after the data is replicated, so it means it's all the replicas we will not miss any replicas. And you can see it's different with the segment X, because it's here it's a concept in Bookie is because if here you can see we don't have any segment over here, and the Bookie side will handle this case internally. It looks like one segment. You also can have multiple fragment. Yeah, I can show here. It's just a concept in the Bookie side. It's Pulsar. If in the Pulsar side, we can see it's multiple segment in the partition or topic, and essentially it's a ledger in Bookies. But in Bookies, it's one ledger can have multiple fragments. It looks like the fragment 0 is data is distributed to Bookie 1, 3, 4, and the fragment 1 is the data can distributed to broker to Bookie 0, 1, 4. It's because the Bookie 2 is not able to provide the services. So yeah, so this is how Pulsar are handling the broker and Bookies failure. So you can see it's no matter the broker or Bookies, it's failure. No matter the failure has happened on the broker or Bookies, yeah, it's for the topic or the application side. Yeah, you can see it's the impact is looks like it's maybe only a few milliseconds. Yeah, so this is why Pulsar will have a multi-layer architecture to be able to handling the failures well. Yeah, and even if you have a geo-replicated cluster, then you can also to avoid the single region failure. And because in Pulsar, it's for the geo-replication is happened in real time. It looks like the one cluster, if the producer publishes the data to topic X, and the data will replicate it to other clusters immediately in asequence way. If you have one cluster, it's not able to provide services, and you can also get the data or maybe all the data can replicate it to the region B and region C. So you will not see the data lost here, even if the region A is not able to recover. Yeah, but yeah, here is details is because it's in the asequential way. So it's maybe the some tuning data is not able to replicate it to other regions. So yeah, it's just not a big impact to for this case, because yeah, you already have one region is a failure. Yeah, but if the service is able to recover, yes, the data can continues to replicate it to other clusters. Yeah, so yeah, you can see in this case, if you if the one region is not able to provide the service, and you can try to let your consumers and the producers to try to connect it to another region, and the Pulsar also support to replicate the subscription states. It looks like the offset in Kafka or in Pulsar is marked delete operation. It's looks like the operation that's where the consumer that's consumed, and so you can safely to change your consumer to connect to another cluster to continues to consume process the data. Yeah, and yeah, and the last one is I want to talking about the operability. It's because it's looks like it's major difference with other systems because you have brokers and bookies, and for Pulsar's design is try to minimize the impaction and the compatibility. Yeah, for scaling the brokers, let's say, yeah, if when you need to scale the brokers, it's maybe many reasons. It's for the throughput, if you want to increase producers to handle more workloads, or the topics or the connections is increased, and you have more and more producers and consumers. Yeah, and as many reasons, it's just to say what will happen when you scaling a broker. It's what will happen in a Pulsar cluster. Yeah, for example, if we have 3 brokers and 7 partitions, and broker 0 have 3 partitions, and broker 1 and 2 have 2 partitions. If you add a new broker here, what will happen? It's some of the partitions will migrate to the new broker automatically. It's based on the Pulsar load balancing mechanism. It's the same with the case of the broker trust. It's because it's just the topic ownership change. It will happen in milliseconds, and oh sorry, this one is scaling bookies. And when to scale the bookies, it's maybe also related to the throughput, because the bookies also need to handle the data write operations, and because for the read is in Pulsar, if you just read the latest messages of the topic, because the broker side have the cache for the topic, the killing cache. So you can for the consumers, it can hit the cache as just to read the data from the broker cache. But for some cases of the catch-up read, looks like you want to read the historical data, so it will go to the bookies, try to read the data. Yeah, so it's a little different. And for the bookie side, I think the major reason is you want to scale up your bookies. It's about you want to have more data to be retained. Maybe it's more data right to the bookies, but you don't want to remove them. You need more spaces to handle such the increased data. Yeah, and so we can say what will happen when you scale the bookies. Here you can see we have 5 bookies, and it's one partition. Also have 5 segments, and the last segment is the active segment. And if you add more bookies, and because it's the segment rollover, it's for Pulsar, the segment rollover can based on the segment size or the segment time. It's for example, if you want to roll over a segment in 10 minutes, or the size limitation or 2 gigabyte or something, and for the new created segment, it will try to select the new bookies, new added bookie for segment X, Y, Z, and so you can see it's here is we don't have any data replication. It's happened. It's because just the new writing data will write to the new bookies, and because you have the data retention, and the old data will be removed automatically. And for example, if the segment 0, 1, 2 is removed, so the bookie 0, 1, 2, 3 will have more spaces, can store more data. So it looks like automatically data rebalance mechanism for bookies. It's this way is you don't need to do some additional operations, rebalance or something. Yeah, you don't need to do it. It's just adding the bookie node to the new cluster or adding the new broker node to the cluster. Yeah, so this is about the scaling. And yeah, even for upgrade and downgrade, yeah, I think for infrastructure system or the messaging system is used across multiple teams. Yeah, I think it's a pinpoint how to upgrade the cluster because it will introduce risk, right? And so I think because the Pulsar have multi-layer architecture, I think the advantage for this case is usually I think you don't need to upgrade the bookies because yeah, for the bookies it looks like more stable, and we don't have many new features to the storage side, and so yes, the many functionality for Pulsar is happening on the broker side, like bug fixes, enhancements, or some performance improvement, admin APIs, or some new features. So you only need to upgrade the broker, and the broker is stateless. So even if you have the issues during the upgrading or downgrading, the upgrading, yeah, it's easily to stop the upgrade just to downgrade a broker or shut down a broker. Yeah, so it's looks like to minimize the risk will introduced during the upgrade or the downgrade. So yeah, this is the advantages introduced by the multi-layer architecture. Yeah, and thank you. And this is all the stuff that I want to share. And if you have any questions, and maybe you can just open your microphone or type in chat.
Yes, thank you very much. If people in Zoom have questions, please add them in chat. I will ask my audience here.
Yeah, thank you.
Anybody has questions? I think you come forward. Looks like you gave a perfect presentation. Nobody has questions. Thank you very much. Thanks everybody for coming. And we're looking forward to see you in the next meeting.
Thank you.